Following on from the previous video, we got to this stage here where we've got a formula for our area here. When we try and sketch this this graph here, it looks like this. Okay, and this point here seems interesting, so we're going to investigate this point here. So this point here will be when the gradient will be 0. So we would differentiate a with respect to x. Okay, so that would then give us this. Okay, so this a differentiating a with respect to x seems a bit, it is quite strange, but the thing is, you've got a graph of a versus x, so you just blindly shut off your brain and just differentiate it, find the gradient. So this here represents a gradient, and just find out when this equals 0. Okay, I know this seems quite strange, differentiate a with respect to x, but just differentiate it. That would then give you this. Okay, so find out when this equals 0. So set this to be 0. So let's let it be this, and then add 1 over x to both sides, blah blah, and then x equals this. You see, when x equals a half, the gradient is 0. So what that means is at x equals a half, the gradient at well, don't forget this is a versus x here. The gradient at x equals a half will be 0 right here. Okay, so we know that there's a turning point at x equals a half. So let's find out the value here. Okay, so we've got to put this half into the original a. So wait there. So remember, the original a was also this. Earlier we used this. Hang on. Earlier we used this here, but don't forget we can either use this or we can use this. Hang on, or we can use this. It doesn't really matter, but it turns out that this one here is slightly easier. So remember, hang on. We know that when x is a half here, the gradient of this graph here will be 0. Okay, so let's find out the value here. The value here. What is this value here? Okay, what is this value here? So let's put a half into here, and then into here. So that would then give us this. Hang on, that would give us 1 over 32. Okay, so what that means is that our graph looks like this. Our graph looks like this. When x is a half, the value here will be 1 over 32. Okay, and then also we still need to find out what this value is when x is 1. Okay, so when x is 1, put it into here. So a of 1, put it into here, blah blah blah. It comes to 1 over 16. So looking at our graph here, hang on, looking at our graph here. When x is 0, it is 1 over 16. When x is 1, it's also 1 over 16. So in a way, it's kind of symmetrical along here. Okay, this here, well, remember our graph is area versus x here. So we can slide x back and forth here, and then up here would represent our area. You see the answer to our problem here. I asked you, where should I cut the wire in order to produce the maximum area? Well, if you say cut it at a half, that would give us the smallest area here. So, well, to answer the question here is that, in a way, it's kind of a trick question, because the answer here is that if you have a wire of length let's say 1 meter, where should you cut it in order to produce the biggest of the two areas here? The answer is you shouldn't really cut it, because if you look at this here, as you move x across, if you cut, as you move across, then you can see the area will decrease. So the answer, in a way, is kind of a trick question, because you shouldn't actually cut it. But if you're forced to cut it, then just say, oh, cut it at x equals 0.0000 whatever here. Make x a really small number if you're forced to cut it, or make it really really big, so it's around here somewhere, 0.999999. But the thing is, We could say it's a trick question, but then on the flip side, you should, if you truly understand the situation here, then you could actually, you should be able to, you should know that, you sh well, I don't know.